All right. So we were talking about how to find the concentration of a solution. And what are our units for concentration?
Molarity.
Molarity, which has to do with the number of moles we have in a certain volume. So the other thing we can look at is what happens if we dilute our solutions. And you're used to diluting things because like you get those frozen cans of juice concentrate. What do you have to do with them before you can drink them? Can you just pull it out of the freezer and thaw it?
No, we always have to add water. Like
Right.
3 or 4 cans of water.
Because otherwise it's way, way too strong. And so if your solution is too strong, what do you have to do?
You add water.
You add water.
Which
you
is
add
going
your,
to...
be your...
That's your dilution.
That's your
so
solvent.
You're adding your solvent to dilute it.
Right. So this is the math on that. And the nice thing is, it's one fairly basic equation.
I like basic.
So our equation for dilution problems is going to be M1V1 equals M2V2. And we looked a little bit back in the last video. What do we do? What do we get if we multiply molarity times volume? What quantity does that give us?
The number of moles.
So if all we're doing is adding water, is our number of moles of our solute ever going to change?
Nope.
No. So what this is telling us is that our number of moles is constant. All right. So let's look at how we do one of these problems. It's really pretty straightforward. So what's it telling us?
All right. What volume in milliliters of water would have to be added to 150 milliliters of 0.450 molar potassium chloride, KCl, to give a solution with a concentration of 0.100 molar?
All right. So it's a little bit like we just did, a little bit like back when we did in gas laws. We've got to identify what we know.
All right. So we know that we started with 150 milliliters of water, so that would be our
150 milliliters of our
solution.
Yeah.
150 milliliters of solution.
Okay, and what else do we know?
We know that the molarity of the solution is 0.450 molar.
All right, and so...
And we know that we're going to add some water, so our solution is going to have a volume.
Right.
And we know that the new molarity after we add that amount of water should be 0.100 molar.
All right, so now we've got 3 of our things. We're looking for our 4th. What do we do now?
Let's take the numbers and replace them into the equation.
All right, so let's plug things into our equation.
So we got 0.450, which is our M1. Our V1 is 150. That is equal to 0.100 times our new volume.
All right, so we've got all this plugged in. What are we going to have to do to get our V2 by itself?
We are going to need to divide both sides by 0.1. So
right.
In the calculator, let's do 0.450 times 150. Divide that by 0.100, and that should give us what the new volume is going to be.
So our new volume is going to be 675 milliliters.
All
So
right.
you may be asking yourselves why we didn't have to change our milliliters into liters. Back when we were doing just molarity problems, we had to do liters because that's part of the definition of the unit. But the nice thing here is, just like in volume on gas laws, when we had combined gas laws, it's either going to be milliliters on both sides or it's going to end up milliliters because those are your only units left. So don't worry about converting your volumes when we're doing dilution problems. All right, now the last thing we have to look at is the question actually asking us about our second volume?
No, we want to know how much has to be added to the 150 milliliters already there.
Yeah.
So what we have is what the volume should be.
Right. But we need to know how we got there. So how are we going to figure out how much water we have to add to go from 150 to 675?
We need to subtract 675 and 150. And that'll tell us how much water you have to add.
So if we subtract our 675 minus our 150, we end up needing to add 525
So we need to add 525 milliliters of water to our 150 milliliters of solution.
So that our final volume is 675.
And
See,
with the molarity of 0.1.
this is actually as complicated as dilution problems you're going to get. Isn't
Yeah.
that fantastic? All right, let's try. Actually, why don't you try your guided practice on your own, because that's really all we need to teach you. And come back and see us here in a bit, and we will see how you did. Hopefully, you try this on your own. Here's your first guided practice problem.
All right, so what is the new molarity of 250 milliliters of 0.500 molar NaOH is diluted to 1.5 liters? So we write down what we were given. We were given our first molarity of 0.500 with a volume of 250 milliliters. We want to know what the new molarity is. And we know that the volume was changed to 1.5 liters. So earlier you said we have to either do milliliters or liters.
Right. So the one time you do have to convert in dilution problems is if they don't match. So what's your favorite? Do we want to convert our milliliters to liters or our liters to milliliters?
Let's do liters to milliliters.
All right. So we have 1.5 liters, and we know there are 1,000 milliliters in a liter.
So if you take 1.5
times 1,000, so that's going to give us
1,500 milliliters.
There we go. All right, so now we've got all our information. What are we going to do?
Let's plug them in. 0.500 times 250 milliliters equals, we don't know what the new molarity is going to be, but we know that the new volume is 1,500 milliliters. So we need to plug in our calculators. 0.5 times 250, and then divide that by 1,500. That should give us our new molarity.
So our new molarity is going to be
0.83.
No,
0.083 molar.
All right, so if we take a little bit of liquid and dilute it to a lot, our concentration goes down a lot.
Yeah, so that kind of makes sense.
All
okay, I see one more on the horizon.
One more guided practice problem. All right, and now for your second guided practice problem.
What volume in milliliters of water must be added to 12.5 milliliters of concentrated HCl, 12 molar, to make a 0.250 molar solution? So, let's see what we got. We have an initial molarity of 12. That's potent stuff. We don't have a whole lot of it. 12.5 milliliters, that's a T90 amount. We know what the new molarity needs to be is 0.250. That's way lower. Probably much safer too, if I had to guess.
Yep. 0.25 molar, something we'll let you use in lab. 12 molar, not so much. Maybe in AP. All right.
Okay, so we've got our list made.
All right.
Now what we want to do after we've made our list
is plug everything into our equation.
All right, so I've got 12 molar times 12.5 equals the new molar, which is 0.250. There we go. Times, space. Oh no, we don't know what it is.
All right, and so just like all the other ones,
multiply 12 times 12.5, divide that by 0.25, and that'll give us what the volume should be.
The final volume should be 600 milliliters.
But this is another one like the practice problem. In the notes, we want to know how much has to be added to the already 12.5 milliliters.
Right, so if we start out with 12.5 milliliters and we want our total volume to end up being 600, we're going to subtract. So 600 minus 12.5, we have to add 587.5 milliliters.
That's a lot of water.
It is, but we want it to be a lot diluted. So.
That's true.
All right, so if you're still having trouble with this, ask your teacher. Otherwise, go forth on your practice. Have fun.